Raju has responded. Let us wait for some more minutes.
Yeah, hello team.
Sir, good evening, sir.
Yeah, good evening, ma'am.
Yes. Parvati, please introduce him.
Yes, ma'am. Good evening, dear participants. We are about to start this first session of the day 3. Hello. Hello.
Admins, could you please make the speaker as a co-host and mute the remaining or?
Ms. Jayanti N, can you mute your mic? Ms. Jayanti N, can you please mute your mic?
Good evening, dear participants. We are starting with the first session of the day. The first session today focuses on an important and contemporary topic, which is cloud in research and industry, highlighting how cloud technologies are shaping modern research practices and driving innovation across industries. It is my privilege to introduce our first resource person of the day, Mr. Jacob Thomas, who serves as the delivery manager at TCS Kochi. He brings with him strong industry experience and practical exposure to enterprise-level cloud solutions. His insights into the role of cloud computing in both research and industrial environments will be highly valuable to all participants. Sir, we are honored to have you with us today. I kindly invite you to take over the session and share your expertise on cloud in research and industry. Thank you, sir. Thank you, and over to you, sir.
Thank you so much, Parvati. Let me first of all apologize for being 10 minutes late because I was under the assumption that we'll be starting only by 7 o'clock, and extreme apologies for joining 10 minutes late. Just give me a minute. I'll be sharing my screen shortly.
No problem.
Okay. So before we start, I just wanted to understand that this, I believe, is a faculty development community that I have here, right? So do I have faculties from only Adi Shankara, or we have faculties from all other colleges?
So we have faculties from all over India, sir.
Oh, okay, really great to know. Thank you so much. Just give me a minute. I'll share my screen. Right. Let me know once you're able to see my screen.
Yes, sir, it's visible.
Okay. So thank you so much again for inviting me to this event, especially the faculty development program of Adi Shankara Institute, and special thanks to Adi Shankara Institute for hosting this, as well as continuing the relationship with the Tata Consultancy Service where I'm working. So to start with, basically, I understand this entire session of programs for the faculty is mostly to sensitize them about the cloud computing aspect of it, not just restricting to cloud, but also to the edge computing, what it is, how it is, and what is the different areas which are getting impacted by its evolution. Now, let me tell about a bit of history. Like when we initially had servers, or the concept of servers, it was mostly on-premise in nature. There were a lot of LAN and cables that were laid down, and starting right from the mainframes, wherein we did not have much of internet during that time. It was mostly to do with a one fused system, if you ask me, wherein there will be a DB2 database, and there will be a front end which doesn't have much of a UI. It will all be the black and white screen. So those were the initial 80s IT, if you ask me. Now, from there, there was this drastic explosion, which kind of took the application into a different level. Especially, as I said earlier, when the internet came through, we were able to transfer data alone in packets, and we were mostly able to do that, and it did not have fused servers or fused database, but we were able to keep separate. That's database is separate, front end is separate. There will be the middleware layer or the API layers that came across. And fast forwarding into 2024, we are close to around 700 billion revenue, and 700 billion in market cap, if you ask me, in terms of the cloud revenue that we are talking about. And in 2025 alone, this has grown by 400 billion. Now you can imagine the compounded annual growth rate, or CAGR, as we talk about. So that is the market value or the scale in which it is growing in industry. Now every organization is behind the cloud because there is application. And every company is not just a organization, but it's also transformed into a learning organization. Now, when we say learning organization, it is mostly to do with data that they have in place, historical data, analytics. If you look at any business, be it a bank, in our traditional banking system, it was more of a transactional place where they used to have ledgers, and then transactions was recorded in ledgers, and once we had one, just give me a minute. Yeah. So once we had our databases, these databases were later evolved into a specialized Oracle or other systems. So now, sorry, I'll just share my screen again. Yeah. So once we had this particular databases for the banks, this also evolved later into specialized bank-friendly, like Oracle or the Finnacles of the place. And at a later stage, once we had this, the business also transformed. That is, different business models were evolved. They also started selling insurance, and at a later stage, it also went up to the UPI level. Now, if you ask me, in a traditional banking system, or how does a typical ATM works? Once you take the money from the ATM, this particular ATM has a ledger on its own, and immediately after you take the money out of the ATM, if you check your balance, I'm sure it would not have been synchronized, because once you get an SMS, this particular ATM has to communicate with the servers, and this particular servers will be having a copy of your daily transaction, and this will be written only to the master data of your bank servers, or bank central servers, as we call it, by the end of the day. So we are still dependent on this set of processes. So this processes also has evolved in its across a span of time, because when we speak about, I'm not sure if you have heard about the ETL systems, the extraction, transformation, and loading. When we say that is mostly to do with the database taking, we make the changes in the database based on the day-to-day activity, and then we upload it, or we kind of replace the this thing. So now, what is the role of cloud computing in all this? Now it has all happened, or any tool that you talk about, be it the data stage or the Informatica, or in the new AI era also, all the tools need a place where it can scale up. And this scaling up was made possible with the help of the cloud computing. So that is where the cost reduction, in terms of like we can take it as a service. I remember when TCS used to go to this small and medium scale enterprises, like, to give an example, be it the Kontodi Travels, if you know, or the Melam Masalas, which are all small and medium scale enterprises, we were able to sell them what is called as a ERP, the Enterprise Resource Planning tools, at a very just medium rate of hardly like 50,000 or 1 lakh rupees rent on a monthly basis. So they did not have to do anything, but all we could give them is a instance of the cloud, the hosted application on the cloud, and we will be just hosting it in our EC2 bucket or so, and we will be able to give it to 5 or 6 other vendors, and they will be able to, and we just need to make sure that we have separate database instance, but the same application is being utilized. So that is the benefit that this particular cloud has brought in. And if you ask me, it is a very explosive, or the technological explosion is what has happened with the help of evolution of cloud. Now coming to the performance, we have seen a drastic increase in performance. We use the term latency just to make sure that there is no delay, because delay in business, especially if you are talking about a business like banking or in a share trading, wherein even the seconds matters. So in a business where latency is really a matter, then cloud has really helped us give a lot of RAM space. I'm not just talking about the storage space, but we are able to scale up and we are able to process information at a needed space, and that too whenever required. I remember when we were working for a project which required its quarterly results to be published in a website, we would be bombarded with 2.2 million hits to the servers, and after the initial, there will be a lot of chatbot attacks, there will be a lot of bots that come from the media, because these medias and all need to crawl through the website and get as much information as possible so that it can be reported first. Because in a world where news has to come fast, or it has to be posted in social media, then it has to be crawled, and these days this crawling is also done by bots. And so in a drastic 2.2 million hits, after it reaches the caching or the direct server hits, we were able to scale it up, and the delay in instance is something that we couldn't afford. So the crux of the matter, what I'm saying is, we were able to scale based on the need, and we could easily scale it up to 2.2 or up to 5 million based on the requirement. On a normal day, it would be hardly 1 lakh people who will be visiting that site. So similarly, now coming to the last part of the cloud revolution, it has also helped us innovate faster in terms of process, because as I said earlier, right from the ledger system, because if you look at any organization, be it any NGO or any bank, you will find something like the trial balance sheet, P&L. So all this ledger system, this consolidation, we were able to make it change through a single source of truth. Now that is where innovation plays a role. Now when it comes to cloud, we made the same thing accessible to all. Because if you ask me, in the 80s, in the 90s, or in any organization, the major problem that occurs is with respect to the communication, is with respect to the difference of data. I mean, even if it is in your organization, imagine like how it would have been 20 years back. You had to come to the college, you had to sign a ledger stating that, okay, you came in this time at this time. And what has it changed to? Now it has changed to either you swiping your card in a sensor, or you are putting your fingerprint, the biometric is tracking your record. So what happens is the administrator of the office get a report, and similarly that particular process has been automated. So similarly, there is a lot of innovation also which cloud computing has been has empowered. All right. Right. So let me not go into definitions, because I understand all of your faculties, and going into definitions is kind of very trivial. But then when it comes to cloud, I'm sure all of you know that in the industry, enterprise, mostly the market share is had by the AWS, the Amazon Web Services. Then we have the Microsoft Azure, which kind of comes at the second place. And I'm not talking about the traditional giants. Okay. If you ask me, the traditional giants like the Oracle, the SAP, and all, they are all traditional people, but their focus is more on the products that is there in the cloud rather than in the cloud services assets. So if you ask me, AWS, Microsoft Azure, GCP, those are the most premium clouds which majority of our customers prefer, and we also recommend them to the customers. But then is that totally safe, or what are the problems that it brings with? So in an industry, when any company comes to us, we tell them that, okay, if you are essential that you need to scale, then use cloud. If don't, then no need for a cloud. You can even host anything in a server, like in an on-premise server, if it is totally based on your LAN network. If it is if it is an application which requires only your employees to access. But then now what has happened is everybody has a device. Now, when it comes to the device, it could be any device. I remember when we were approached by a logistics company, they came to us and said, can you help us or can you help our employees track the package and also make a route, that is the minimum route that we can, or the employee has to go to drop this particular package in the address. So it is more like a the information that has to come. Now there will be a lot of routes that comes, like he has to deliver a package at a certain place X, and then there will be 5 or 6 packages which he has to. So it's more of a traveling salesman problem. That's what we call it in the operational arena. So a traveling salesman problem is where he has 5 packets and he needs to optimize that. How do I travel so that I have to travel minimum in order to deliver this 5 packets? Now this with the help of, I mean, currently, if you ask me, it's pretty easy when it comes with, when we are using the logic of like the Uber. If you are going from place A to place B, the Uber takes you through the shortest route possible. Again, they are collaborating with Google Maps because they have the data available. And if there is a traffic in place, then they kind of reroute it, right? So if you ask me, this has been empowered or enabled with the help of cloud computing, right? And yeah, then yeah, sorry about that. When we are looking at cloud as a service, or as I said earlier, we are also looking at cloud as a business innovation tool. Now, what does business innovation means? Basically, when it is more to do with the process, or when it is more to do with a technology. So
PPT is
many,
not visible.
sorry. Oh, sorry. My bad.
PPT is,
Okay. My bad. Sorry. Are you able to see now?
yes, sir.
Okay. So when it comes to cloud computing, or when it comes to business innovation, so now most of the business innovation or the definition of the business itself is changing. Now earlier we were discussing. Now there were banks. Now when people does not visit bank, one of my friend who is actually a bank manager, who is in a probation officer, what he said is, there are banks which are running on the revenue that is generated by ATMs nearby. So that is the scenario which they evolved to. Then they started cross-selling insurance. And at a later stage, when UPIs came along, when there was Paytm, which was acting as a branch or acting as a bank without a single branch, it's all over the internet. And then at a later stage, when blockchain came into picture. So we are talking about different technologies which doesn't require a physical space. There are no longer brick and mortar shops that is required to run a business. Even every YouTube video that you see now is kind of telling you, okay, you can start a business even without having a place. If there's a virtual space that is required, all that is required is a cloud space. If you ask me, what is a virtual space? It's a website, and then based on their website, where is it hosted? It is hosted somewhere in a cloud, and this particular cloud is telling, irrespective of how much traffic it gets, you can scale up. So it's basically exploring your hope into the cloud, into a space, into selling it, and it is even made it really accessible for anybody. Okay, and now what are the advantages by which we can get it? Now, if you ask me, earlier when we had to set up a cloud, we were just given, okay, now I'm sure all of you would have heard about infrastructure as a service, platform as a service, software as a service. Now now we are also hearing BaaS as well. Okay, now real-time monitoring is an advantage which we have. Like there are different tools by which we will get to know what is the advantage that, or what is the traffic that is happening in the cloud. Do I need to scale it down, scale it up? And this most benefit comes in terms of the amount of money that you need to spend based on the traffic. So if there is a high traffic, you need to scale up, you are able to spend only that much. And if it is the time of say like your quarterly results, the example I was giving, or it's the time of the black sale for a e-commerce site, so you need to make sure that irrespective of the number of hits, be it even 1 million, so the site shouldn't crash, because that is the lifeline, the bread and butter. And this 12 hours during which the Black Friday sale happens, the site has to be up and running. So what is required is real-time data. And again, let me give you another example of real-time data. I'm sure all of you would have used this Instamart or Zepto. So if you try buying vegetables, let me give you the example of vegetables, because I myself have had this experience several times. When you order in the system, there is always, like, if you want to say for example, 1 kilogram of tomato and 1 kilogram of potato, and you keep the order. By the time you place the order, that is when the real magic happens. Because the instance when your front end or your mobile application is seeing that 1 kilogram of tomato and 1 kilogram of potato is there. When you place an order, and when this place order button is clicked, the API behind goes and gets the actual units or number of units in the warehouse. Then if they don't have this 1 kilogram of tomato and 1 kilogram of potato, which was shown to you in the front end, then they will not be able to cater to it. Then it is an unhappy customer. It is a lost business. All right. So that is where we are talking about latency. And if the instance which is there in the mobile, that's the data instance which is there in your mobile, is really giving you real-time data. Because earlier we used to talk about real-time data, near real-time data. All this is very essential, especially where the example which I told you about the tomato and the potato. So imagine if people, or I myself, who was earlier purchasing the vegetables from the shop, after two such experience where I ordered for 1 kilogram, but the system logic reduced it to half a kilogram based on what is available in the inventory and based on how they can cater to maximum number of users. That is a business logic which was written. I started not placing orders, but instead I directly went back to my older vegetable shops. So now you understand how a business will be impacted if we are not giving them proper scalability or real-time data availability. All right. Now, similar is the example with supply chain, where we can have a robust and agile information pass through. And I remember where this particular Amazon, now everybody is in Amazon. So now Amazon returns because this Sunday I placed an order for a small item. But because I was not able to find that item, and my son was pestering me, I thought, okay, I will buy it because it was costing only 120 rupees. And this Amazon Prime has kind of made me really lazy that irrespective of whatever price it is, they don't charge for any courier. So I'm happy. Even if it is costing me some money, I've become so lazy that I will go and order for it. But what happened is, after 20 minutes of placing the order, my son really found out that it's an item which is available in my home, and he found it out. Then I went and after 30 minutes, when I came back home, he said this is available. So I went and canceled that order. Now, what I'm seeing is the information which I am available, or which is available to me, states that by the time, that is the duration, by in between the duration of this 1 hour, the particular application or the particular thing has been packaged and it has been sent to a common warehouse. And this is happening in between Pune and my location here in Kerala. Now, from the Pune, it has started. It has went to the Pune Amazon warehouse. And by the time I clicked, then that information which came on the next day states that my package is received in Bangalore. Now, this shouldn't even move from Pune to Bangalore because I cancelled it before. But the information did not reach the logistics people on time, or it was already parceled for a flight journey from Pune to Bangalore. So my parcel, irrespective of me cancelling it, has made a journey from Pune to Bangalore. And then after 24 hours again, I'm seeing that it has moved back from Bangalore to Pune. So there has been a logistical travel which was totally unnecessary, and it could have been prevented if the system was much more robust in nature. All right. So we would think that it is really, really trivial. However, I'm talking about a 100 rupee thing making a business flight, and that 100 rupee thing would have been less than 100 grams. But for logistics companies, saving such things really matter. We are talking about Apple companies saving in logistics by cutting down on its charger. Okay. Now, coming to the final, that's a low latency edge. Now we are looking at the the latency. So we were discussing about the data transmission delays. So if the data is transmitted on a faster real-time basis, then there is a lot of information exchange that can happen. Now imagine in a particular shop floor, or in a particular, I'm sure in all service systems you will be or imagine you are giving a vehicle for your servicing, and in every servicing center mostly you will see, there will be a television which says this particular vehicle is in progress. So that visual radiator is there, and this visual radiator is connected with a device which is currently with the technician. Now this technician will be connecting this device to your vehicle. Now gone are the days where they go and repair. It's all assembly now, and even if it's in repair, they will not repair the sensor, but instead they will just replace it. So every workshop has now become an assembling unit, because it's not worth repairing it, but it is assembling is what is actual process that is happening. So they will just make the change, and you will be able to see that in the visual radiator if you are in that place, or you will be able to see it in your mobile phone, or you will be able to get it in your website, or you will be able to get it in your SMS, right? So that is the level of industrial explosion, or that has really happened. Now, before I proceed, any questions so far, or am I audible?
Yes, sir.
Yes, sir,
Yes,
you're
sir.
Okay. Okay, fine. So I believe there are no questions. I will proceed to the next slides. Now, coming to the business benefits across different sector, most of this have been covered through my story, where the cost efficiency, we are talking about the capital expenditure and operational expenditure. Now, what a capital expenditure is basically, if in a company like TCS, we are purchasing laptops, then that is a capital expenditure, because we are investing in a laptop which has to be used for the organization. And if in a petroleum company they are investing in a machinery which is used for refinement, then it is a capital expenditure. Now coming to the operational expenditure, it is mostly salary. Now when you speak about the cloud computing unlocking the business benefit, then the cost efficiency is of primal importance, because we are looking at the reduction in capital expenditure. You don't have to buy money in servers, but instead you can purchase, or you can lease, or you can just give money to AWS, and then you can get your cloud instances, and they will make sure that your business runs promptly. And if your business is having a downtime, then you need to pay only as much as necessary. Yeah, as you see, it is pay as you go operational expenses. So reduction in operational expense, and shifting from capital expenditure to operational expenditure. Shifting as in from the on-premise server which was there in your computer. I'm sure all your computer labs, if you go, there will be something like a rack server where you will see a glass, or sometimes it might be an air-conditioned room. So the air conditioning expense is there. So the rack server expense is there. This lab assistant has to be there. I think lab assistants will be more of an operational expense. But then all the hardware infrastructure which has been purchased in terms of the capital expenditure is now moved to or migrated as operational expenditure. So there has been a change in expenditure nature. But then, and also operational expenditure is very less than the capital expenditure. Now coming to the global agility, we can reach out to servers in the globe anywhere. Whenever I get a call from any of this people, like mostly from the banking area, they will tell, sir, why don't you invest in stocks from Google and Tesla? I said, come on, I am in India. How can I do that? They will tell me, you can do anything, sir. Sitting here in India, you can invest in that. I said, no, it is a very share market thing. They said, no, you install this application, you will be able to reach out, and you will be able to within seconds. So we are talking about a fraction of a seconds, where even if the value of that share increases by cents, or if the value of that options increases by cents, we have to place the order. So now we are talking about global agility, which is making the world seem like a very small place. And coming to the advanced security. Now, security is basically, if you ask me, it's a double-edged sword. We look at security from different standards. Extremely sorry, it's actually SOC standards, and then HIPAA, as well as the global data protection rights. Now, coming to security, there are different countries which has different set of security. Now, in Europe and all, GDPR, or the global data protection, is considered very high, wherein any personally identified information, the PII, or any data which can indirectly lead to you, that is your phone number, your PAN number, something of that can also be, you can't allow it to be directly dealt with. Okay, so what the cloud is currently doing, they will tell, okay, we will store only the hash value of it, which means nothing but it's a secured hash algorithm. Most probably they will be using a SHA-256 or something, and then they will store it in a very secured fashion, is what they say. Okay, and now which will kind of prevent your SQL injection or data leakage in the cloud, which is much more secure, is what it is claimed to be. However, when we go more for an AI, also the same thing is coming as a contradictory thing. How secure is my data? Now coming to the workforce transformation, we said earlier the businesses is transforming from different. Now banks are becoming insurance selling places, or any potential application is becoming a bank. Even the WhatsApp, which I used to chat only, is now allowing me to send money. So I don't need to bank. I can send money in the night or in the morning, irrespective of the time. Okay, so business is transforming. So similarly, the workforce also has to transform. Now I am able to sit at my home and discuss with a customer in a different location. I am here to sit and I am able to talk to you who are from different parts of India, all with the help of the cloud. And also during the time of COVID, especially when there was this education through that's online, that's a screen-based learning, then it was more of a cloud people who really benefited, because they were selling products which could be hosted, and then you just need a cloud instance. So it's more of a subscription basis. That is, the channel alone was we used to call it the channelization. Like if earlier you need to buy a product, then when it comes to channel, you just need to subscribe, just like a Netflix basis. Fine. Now coming to the road ahead, what are the emerging trends? We are looking at serverless computing in the future, wherein the infrastructure. Now coming to cloud itself, I'm sure you would have heard about technologies like Docker and Kubernetes and all, where we, instead of having a in a cloud or in a VPN or in a VPN tunnel. So VPN is nothing but it's a virtual private network, wherein using VPN, we go to a virtual space, and inside that virtual space, which is created by my customer or by anybody else, I will be going and sitting and working there. And an entire Windows machine would be churned up over there, along with a set of applications that I need. If it's a bank, then I can just have every bank connected to my server, and inside that particular server, I'll be running my Finacle application, which will be making my application secure from the external environment. Now, all this can be done with the help of a cloud. Okay. Now, coming to the emerging trends, we are looking at more such virtual instances where we don't need a server in place, but we'll be able to make sure that the end data is correctly transferred to the place where it is required. Now, coming to the 5G integration, we are looking at Starlink. I'm sure all of you have heard about Starlink, where our own favorite Elon Musk is using his satellite to give us internet. And gone are the days where we used to wait for movies to be downloaded through torrents in hours. We can now get it anywhere. Now we are speaking about the ultra low latency. Okay, now I mean we live in an era of hyper and ultra hyper personalization, ultra low latency. All right. And then coming to the AI adaptive service. Now, if you ask me who benefited the most out of AI, I would say it is mostly the cloud people, because they were able to integrate AI into the particular application, and they were able to sell an instance. Now, what you are basically getting is a AI instance in which you need to pay for the tokens. And this particular tokenization, obviously for the large language models, there is token cost involved. However, the cloud was able to sell that as a service, and we really do not know what is being given by the LLM is really in or out. So the benefit is mostly to the cloud. Right. And then coming to the quantum computing, I'm sure all of you would have heard about bits and bytes. Currently in the computer world, we work with ones and zeros, but in terms of quantum computing, we work with something called as the qubits. And speaking a bit more about qubits, has a value in which it is not just 1 or 0, but it can assume any value in between this. and it is totally to explain. I believe there is a concept called the Schrodinger cat, in which the Schrodinger says, where you never know whether the cat is alive inside or cat is dead, but it can be in any stage between this, right? So that is the level of computation through the help of a that's a quantum computing basics, or the qubits as we call it. All right, and now why is it important is, once this quantum computing is in place, it is said that we can make the calculations really fast. Now, why is it this calculation fast is kind of scary is because I gave you the example of SHA, SHA-256. Now, SHA-256 is successful because we are telling there is 256 characters, which is kind of like if your name is XYZ, you pass it through SHA-256, you will get a certain set of value, which cannot be you put any other character, it will change XYZ1, then it will not be the older one, but instead it is a different hash value altogether. But what we are telling is, if with the help of quantum computer, you will be able to do trial and error, and then you will be able to convert back your hashing into the real value, and you will be able to see what is the actual value. So we are basically telling that with the help of quantum computing, we will be able to decrypt anything and everything in the world. And this was a primary reason why blockchain did not become successful, where we said quantum computing will literally tamper blockchain, because the distributed ledger technology in which it worked, the secured hash algorithm in which it worked, will be totally going for a toss in the quantum computing world. But now we do not know. If you ask me, technologies like blockchain, technologies like AI and all, the world itself is not ready for it, is what I believe in, because we live in an era where trust cannot be exponentiated. And in a technology like blockchain, where the trust is in the system, we still need a bank for us to send money from A to B, and we still need a help desk where we should call. Else, trust in the system is totally a scam. At least that's what I believe. Okay, now coming to the critical challenge. Any questions ahead? Sorry, any questions so far? Okay, I still believe I have 30 minutes. Sorry, 45 minutes more. Any questions so far? Am I audible?
Yes, sir.
Okay, fine. So I believe no questions. Now coming to the critical challenges, the data privacy and sovereignty. Now, especially in the era of AI, where this large language models is trained with the data sets which is spanning in the terms of 10 to the power 28, 10 to the power 30. We were talking about GPT 3.5, GPT 4, which had this set of data sets, and now we are talking about synthetic data, which itself is being created by AI. Now, imagine whatever data we give to the cloud, we never know whether this particular data is used as a tool to train or not. Because imagine when my photograph is being taken and uploaded into the LLM, and it generates a picture which does not seem like me. It has been trained with a lot of data. However, tomorrow we never know whether my data is being used for some malpractice. So similarly, data privacy is always a very big challenge when it comes to cloud, because we never know where is it hosted, or where is it used for, or are they really using it for some other purpose? Because if something is given free to you, then you are the product. At least that's what we need to learn from the social media era. Because if you are in, if Instagram is free, your Facebook is free, and any other social media which is given to you free, then your usage, your analytics, your data is being used back as a tool to sell things across to you. That's the that's the data which we have to make sure that is that we are dealing, or that we are putting into cloud is secure or not. I'm sure you heard about the cyber attack that happened in Tata Motors. There we had lost dollars in billions, because the plant was not able to produce cars for 30 to 40 days. Now imagine the loss that is there, and imagine the reputation loss. So stock market share prices plummeted. So there is a risk in which if a particular system is not secure, be it any company, the data. So then again, coming to the security threats. So yeah, cyber attacks. We were just talking about cyber attacks, and so all this vulnerability is there. And let me give you this example. If you go to the nearest ATM, you will never find the latest operating system of Windows in the machine. The business expectation or the functionality of the ATM is to give you money. That's the level 1 expectation, because level 2 or level 3 is the user experience. So if you ask me, do you really need the latest cloud or the latest latency when it comes to money? I would say no, because people are ready to wait for a couple of seconds in terms of security. So real latency or latency in case of banking needn't be the first priority. But if it is a gaming arena where you are doing gaming, or if it is in the share market, the latency should be really, really low. And so that is where we said, based on industry to industry, the cloud demand or the cloud this thing changes. Now coming to hybrid environment management, we are seeing on-premise and cloud resources based on risk of the people. Like I was telling, for banks itself, there will be a master data, there will be a master copy, and this master copy will be updated only on a daily basis, because we can't afford to have a dynamic data change everywhere. But instead, the bank will have a copy and the ATM will have a copy. And once you take the money, this particular data will be passed on to the bank and their balance will be overridden. Okay, and then that message is what comes to you, right? But then the master data copy, which is there in the bank, has to be overridden at the end of the day. So this is a particular hybrid environment where there is a on-premise as well as a cloud, or this acts as a backup feature. What happens if the entire cloud data is deleted? You have a backup, right? So that backup is really, really essential. Okay. Now, yeah, this was something which we discussed earlier. Now, every transformation project, every project which is calling itself digital transformation, cloud computing remains the backbone, and digital industrial revolution and operational excellence. So till 2030, this will be there, and this is going to, or I mean, in fact, it is already there, and we have a lot of transformation projects which is in place. Now, any questions so far? Because from here, I think we'll be moving on to a bit on edge computing and how is it beneficial to business and things like that. Any queries?
Yes, sir. You just mentioned about blockchain, some
Correct.
words, but is it really blockchain is in cloud environment, or it's undermined separate link altogether?
Okay, let me give you this. If you ask me, blockchain is a collection of a lot of things. One is it has a secure hash algorithm, right? And then it has
Yes.
something. Okay, then it has a distributed ledger technology where everybody has a copy. Okay, now even my potential laptop can be a potential source for the blockchain. Now, if I have 10 or 20 computers, and my computer is also being a potential source. Now, I'm sure if you have used torrent earlier days, you want to download a movie, and 5 or 10 people who are already connected to the internet has a movie. So you're downloading it in bits and pieces from all of this who has that same torrent, what do you call, tenant installed. All right. So now when it comes to blockchain,
Yes, sir. My question
yes.
is it running on clouds?
And no, it is running on different servers, which where your potential laptop is also a server, sir. So the concept of entire cloud cannot be put into a blockchain. But in if you are asking me whether there is a server somewhere, then there is a server somewhere. But it is not just a collection of server alone, because computation is also happening at your system. Did I make myself clear, or did I confuse you more?
No, confused. I'm clear. Okay, thank you.
No worries, sir. Thank you. So coming to the evolution part of computing or the cloud computing as well, we initially had this, if you ask me, operating system. Now there was primarily Linux and primarily Unix, and where we used to interact with the help of shell scripts. Now the difference between a script and a programming language is a script is something where you directly interact with the kernels, and inside this kernels, you are giving instructions to this particular kernels in which you ask them to process a certain set of this thing. Now, this was the first what to say server. If you ask me, this operating system was the initial or the first level of server that we had. Then we had the client server in terms of the communication, because we had a client in our machine, and then we have a server in place. Now the operations can happen in the server after my client gives an instruction, because in this place, in this Unix, it was more like I am directly giving the instruction to my kernel, and that is processing. Now this client server came. Then comes the cloud part to it, right? And then finally comes the edge computing. Now edge computing is one level above the computing, because we are looking at the final places where this data is getting calculated to do the computational service. Now there are drawbacks to it as well as there are advantages to it. Now imagine, how do I put it? Okay, I'll give you this example of a pacemaker. Now I remember when we were working for a life science customer, the life science customer came to us with a demand that if a person who is having a wearable, that is, you know what is a wearable, right? It is like a digital watch. Nowadays, everybody has it. Now this particular wearable is connected to your mobile phone, okay? And this particular wearable can be connected to your pacemaker. Now, based on your pacemaker's battery, it can be shown in your this thing. That is your watch. And what they wanted is basically, or what they already had is, because a company like TCS does not have the license to produce medical device. We call it so-called medical device. But then based on this pacemaker or the heartbeat, if the particular heartbeat is going down below, then this particular device that you have in hand will take a decision that there is a potential cardiac arrest, and this will intimate an SOS message to whomever your relative is, or if it is a alarm that you have to sound, then it will sound an alarm. So that was one utility which they said can be provided to people. But then this requires something which is like a where my device or particular my end user device had to take a decision, and it is not a, sorry. Okay. Yeah. Okay, madam. I think I'll please be on mute. Now coming to the edge intelligence. This particular edge intelligence has to be in place because it can't initially go to sorry, I was also muted in the process. Now, because this edge devices also will have a set of logic which needs to be processed. But it is always better that such edge devices is required, but then it cannot be applied everywhere, because we are talking about a wearable device in hand, or we are talking about a car which can send an SOS message if it is automatic, if it is airbag is automatically sync, or we are talking about an ADAS system, an advanced driving automation system, wherein it sees a particular danger and it stops on its own. And now we are also talking about vehicles that comes with ADAS level 2 or level 3 feature, where I don't know whether it's going to be driving on its own. Now, this particular set of devices will not communicate back to the server, but instead it will directly take decision on its own. So that is something which we call. Now we have the cloud, we have the edge nodes, and finally the edge devices which it interacts with. Right? Now this is what is basically edge computing. Now, is edge computing good? Yes, because it provides a lot of things. It will, it can be put into, as we said earlier, what is called as a hyper personalization. It can give you instructions like, okay, if you're a person who is not drinking water, it can give you instructions based on your skin, this thing that is tone, whether you will be, you need to drink more water or not based on your skin moisture. It will be able to do that. So that is all intelligence being pushed to the end. And then there are areas wherein the particular cameras, if it detects a particular motion, only then it will come into picture. Only then it will start calibrating, and then it can even count. Okay, this is one person going, and then how much is the count? So all that edge devices will be there. Now coming to benefits. Now, why do we need edge computing? Because we are looking at a lot of data, and even analysis of this data is getting in teraflops. If you ask me, you see the picture, right? So gigabytes of data is now in terabytes of data, and terabytes of data has to be crunched or sent to the server, which will again make the system really slow. I mean, slow as in the latency. When I'm saying slow, it's only a couple of seconds that I'm talking about. But we are living in an era where my daughter will get impatient if he or she is not able to get the entire thing downloaded. I'm sure all of you or all of people in our age, we don't mind even if the internet or the streaming gets stuck for 1 or 2 seconds. But just observe the new generation. They are really unhappy when the particular video is stuck for a couple of seconds. They are really unhappy. And I am thinking that even my 100 Mbps at my home, even if when it is stuck, then I mean, how would they have survived during my school days where I did not even know what internet was? So we are talking about the next generation of edge computing, wherein the intelligence is at the edge, and we are not talking about sending the data back to the cloud. And these are the this is good. However, there is a flip side to it. We will discuss that. Now, advantages: it will reduce the latency, it will run the edge applications with much more robustness, because the application doesn't have any connectivity to the server or to the cloud by which it is required to work. And then there is no problem of denial of service, distributed denial of service, all that security checks and all this particular application need not face. And emerging technologies such as autonomous vehicle, Internet of Things, robotics, drones and all, very real application, because I'm learning more about this application of drones during the war that has happened recently, or the conflicts, because we are talking about drones, and they are even being used as a weapon in area. So a lot of research is happening, and the edge computing services, only if the drone sees it's a potential target, it needs to go and attack. So a perfect use case for edge computing, but on a negative sense. Now, negative and positive again is relative. Okay, then coming to migrating to edge computing, we can can there be centralized management possible? We can even manage some of it or part of it as we need. Then interoperability of equipment, yes, it is also possible. Then coming to APIs or extendability, it is flexible. Now, we were discussing earlier about the headless application. I think I spoke to you about headless application, because earlier we had something called as a monolithic application. From the monolithic application, we went to headless because technology agnostic is something which we wanted to have in place. And then also we have support updates. Right. Then coming to the problems with edge computing. Bad configuration is a really poor thing. Then hacking vectors, or the areas by which the hacking can happen. That is, you just need to hack that particular end device. If your this thing is tampered with, or if your vehicle ADAS system is tampered with, then you can easily land up in crash. However, it is not necessary that the company that gives you ADAS will check, but then any tampering with this logic will defer you from insurance. So there is problems of such nature that occurs, and then individual licensing cost will increase.
Thank you.
If you
हा म्हणेल की ताईने फोनही नाही उचलला.
I think somebody will have to.
नाही, मी लेक्चर मध्ये वगैरे होती, आणि मग त्याच्यानंतर मी
Yeah, sorry, I was also saying, but then imagine where we said from the advantages of computing, we moved from the capital expenditure of on-premise cost to a operational cost where licenses did not have to be purchased, But now we are looking at a personalization where licenses will have to be purchased. But then this is more of a cycle which is in a kind of sine wave, where in one trend it will be in place, but then at a future trend when we go for personalization, then it will be in this thing. But after some time there will be some other problem solved, and thus it will go in a cyclic fashion. Right. Any questions so far? I think. No, I still have time. Okay. So right. So coming to artificial intelligence, there is a lot of potential for cloud in artificial intelligence, because what we are basically getting is a dependency on usage of this particular application. We are using LLM, which has been hosted in a cloud. So there is a lot of traffic that is happening in the cloud, which is kind of beneficial to the cloud, because what they want is scalability. If everybody is getting prompt service, then scalability is happening and you are dependent on it. And then the tokenization will also happen. So even if you give cloud charges for free, you can charge it back as a token cost, and both are happy. That is, the service is getting robustly available to the end user, and the cloud services are also happy. It's a win-win situation. Now coming to event-driven architectures, that is only if it is on a need basis. That is on the prompt event, if it is triggered, then only it needs to be in place. And so that is a very big technological advancement. If you ask me, it's a transformational process. Now coming to next generation user interface, it's not just Internet of Things or it's just the sensors, but you can integrate it with literally any potential light changing or any smallest. I was talking to you earlier about the heartbeat. So think about it, any life or any change in technologies, like how do I put it? Okay, now imagine, let me put it into scale. When Palestine was when there was an attack, we were talking about like 4,000 shells being dropped in a fashion, and out of which there was this anti-resistance system which kind of stopped 90% of it. So think about the efficiency or the effectiveness. Anything that was moving was being shot down at the air itself. So we are talking about event-driven systems, not architectures, but event-driven systems. Now, IoT systems, we discussed next generation user interface. That was what where we came to this point. Now, again, it is drastic change that is happening in what cloud is enabling us. Now, coming to quantum computing, we are still taking baby steps, but Google has declared that it has achieved quantum supremacy, which means it is able to stabilize and at least make some calculation with the help of quantum computing. Now, I really do not know how the speed of that will be measured, but let's wait and watch. Then coming to real-time situational awareness. Okay, now coming to IT companies, if you ask me, IT companies like TCS, where there is less of research, more of operation, we tend to study about all this. We tend to study about the progress which is being made by these companies. And many a times there are technologies that come in, but it goes as a hype. Now, we were talking about blockchain earlier. I remember in 2017 when we were going to customers, everybody wanted to join the bandwagon, but then they were not able to get into it because they did not trust the open system. But then when IBM had their own blockchain system called Hyperledger, which could be used, then everybody wanted to do it. But the entire hilarious thing to be noticed is that once you have a control over a system, then it is no longer a decentralized distributed system. So a decentralization is lost when you give the control to it. So it is mostly to be noted that similar is the scenario with the AI. Now, we don't know the potential of it. It has a lot of use cases. Does business trust it? We do not know. There is a lot of hype around it. There is a lot of chips being made by NVIDIA, which is being purchased. There is a lot of companies which are interconnected and they are giving service. But however, has results being drastically transformative or disruptive? I believe this terminology was there in a book. I'm sure if you get a chance, there is this book called Innovator's Dilemma. Please do read through it, wherein you will read about something called as a disruptive. Now, internet was a disruptive technology, but then all these technologies should be tried and tested. So similar is the case with AI. Now, have we tried and tested it? No. Is there a lot of hype around it? Yes. Are we sure it will work? No. So whatever example I gave you earlier, if I have to put something in the ATM near me, I don't need the latest operating system. I just need the ATM to spit out cash when somebody in need comes to it. So similar is the case with AI. I don't need to give it any gibberish, but I want to give it answers. However, the beauty of AI is we are very longer looking at AI. I believe it is after agentic AI, we are looking at AI trainings AI. So that will also happen in 2 years' time. But then it is again something for the system or the countries. Only if there is adaptation of technology will it really catch up. Okay. So I think yeah, with that, some gardener's insights. Nothing more from my perspective. I believe I had only prepared for this. Yeah, coming to IT vendors. IT vendors, like I was telling about TCS and other IT vendors, where there is a change in business model, we also have to adapt. We have to learn what is happening. And then the evolving nature of cloud computing, I mean, lot of predictions, lot of hype cycles, lot of quadrants. Then there is vendor faces the use of a new business model emerging. So, I mean, whenever there is a change in business model, we also have to make sure that whatever we do is of value adding to the business, else we will go obsolete. Right. So I think with that, I come to the end of session. It's only 7:10. So I am open to any questions. I see total of 77 people. I'm glad, because when I started, it was only around 30s. But now 77 people have joined. Really happy to see a huge crowd. Anything that you wish to ask or discuss, sirs and ma'ams? Am I still audible?
Yes, sir, you're audible.
Okay. So any feedbacks are also welcome. If you have some examples, anything that you want to share, feel free. And just to understand, this is a 7-day program, is it?
6 days.
Sir,
6
it's a
days.
6-day program, sir.
Okay. Okay, Ramani ma'am. Yeah, I see. I think the next session is yours, right?
Yes. It's okay, sir. It was so nice to. I was listening to you.
Okay.
I'm sorry. I do not know how I'll go about the next session. Sir, so what do you know? What is your say for the researchers?
Yeah, from a research perspective, if you ask me, they mostly are looking at how can cloud integrate AI systems into it. That is first thing. Okay. And secondly, they are looking at how can we do quantum computing integration, because currently we are looking at only quantum supremacy declared by just one company. Now we just can't rely on, or we just can't be waiting. From the researcher's perspective, you will find very less in terms of cloud in the area of research. And yeah, but then again, it has really helped research in terms of there is tools like EBSCO. There is other research repositories which is now available in cloud, and a lot of papers, whatever has been written, the white papers, the thesis, the hypothesis, everything is there available in cloud. And whatever you need to search, because earlier if a researcher had to go through a 100-page paper and then only derive what is required, currently whatever is relevant is totally available for them. And clubbing the particular cloud capability with the large language model learning capability, you are now able to search with the contextual keywords, and this particular contextual keywords will give the researcher whatever is relevant. So from a researcher perspective, he needs to spend less time. That is in terms of industries, I was telling how innovation has been expedited. Similarly, researchers' research time can be reduced. because this will give them the right set of insights. Ramani ma'am.
Okay, sir.
Right.
Thank you. Yes.
Thank you so much.
Sir,
Anybody?
I express my understanding, then you will
Yes.
tell me whether it's a right or no.
Sure, sir.
See,
Sure.
when you use a client server concept,
Correct.
right? Server is a
Right.
central point for processing. Client
Absolutely.
is accessing.
Client is accessing,
Either
yes.
applications are taking data from the server. It's a client side. That's a user side, right?
Correct. Correct.
But here, the question is here we are referring edge computing, edge nodes, edge applications. All
Exactly.
are from the client side.
All are from the client side, yes.
Yes, that means client server, you are replacing the cloud processing point and the client side, which is referring to the edge. Am I
Absolutely.
right?
The processing happens at the edge itself, sir. The processing happens at the edge or the edge node.
Okay, sir.
It doesn't
Thank
have to. It doesn't have to go to the server to communicate, because we are looking at so fast systems that by the time you go to the server and then come back, the accident would have already happened. The ADAS would have already crashed.
No,
Back to the
sir.
question.
Cloud service also it's a part of a source, maybe source from the some supplier or service provider.
Correct. But then we don't go to the
physically there is a computer system.
yes,
Though
yes,
you are
physically there
using
is
cloud.
yes, sir.
Okay.
You're right. In terms of the server, where there is a physically there is a computer system, but where I'm talking about the edge computer, we are the or the decision is being taken by the edge edge system or the edge node. So it will not go beyond that.
Okay, sir. Thank you.
Okay, thank you so much. So any more questions, discussions? I'll be more than happy.
Dear participants, if you have any more queries, you can post it in the chat box.
Right. So if there are no more questions, I think I'll hand over to Parvati for bidding me farewell.
Thank you, sir, for the valuable and informative session. It was indeed an honor to have you with us, sir. Thank you so much.
Thank you so much, Shani madam. Thank you.
Yeah.
Thank
We'll
you,
be
Jacob,
starting our
sir.
next
Thank you.
session. We'll be starting our next session at 7:30 p.m. We'll take a short break till then.